Hi students, and welcome to this lecture which is based on permutations and combinations. Now, permutations and combinations form a very important part of algebra. They help us to calculate the number of ways in which we can perform any task, whether it is about the setting arrangement or it is about the formation of numbers, whether it is about the arrangement of things in a circle or it is about formation of committees out of a group of people. All these involve the basic applications of permutations and combinations. We're not going to go into the detail of permutations and combinations, but we are going to see some of the very general cases that we come across in permutations and combinations. We are going to see some of the very standard problems that appear very frequently in competitive exams and what should be our approach to handle such problems. So let's quickly begin this lecture. First of all, let's take an example. Let us say that we have got 4 bottles. Now we can arrange these bottles in different ways. For example, we can arrange them in this manner. We can arrange them in this way. We can also arrange these 2 bottles in this way. So now my question is, in how many ways can these bottles be arranged in a row? So you see there are 4 bottles. There can be numerous ways in which we can arrange these bottles in a row. But now, how many such number of ways are possible? That's something we are going to study. Let's take one more example. Let us say that we have got boys and they are sitting around this table. Now, they can be arranged in this way. They can be arranged in this manner. Or these 2 boys exchange their places and they can be arranged in this manner. So you see there are so many ways of arranging these 5 boys around the table. Now again the same question, in how many ways can these 5 boys sit around the table? So you see there are so many ways of arranging the boys around a table. But now how many such ways are possible? That's something we are going to study in this lecture as well. Let's take one more example. Let us say that we have a group of people. Now, can you tell me in how many ways can a committee of 4 people be formed from this group of people? So you see there are so many people. Now I can select any 4 persons from this group. But now how many such groups are possible? So to answer to all these questions, we are going to study about permutations and combinations. We are going to see how the techniques of permutation and combination help us to answer such questions. But before we study about permutations and combinations, there's something very important to study, and that is the factorial notation. Now what is the factorial notation? The continued product of first n natural numbers is called n factorial or factorial n and is denoted by this way. So this represents n factorial. And this n factorial is nothing but the continued product of first n natural numbers. So n factorial would be equal to 1 into 2 into 3 and so on up to n minus 1 into n. It is actually the continued product of n natural numbers beginning with 1. We can write this in a reverse manner as n into n minus 1 into n minus 2 and so on up to 3 into 2 into 1. So the continued product of first n natural numbers is n factorial. So we have seen what is n factorial. Now there's something important to note, and that is when n is a negative integer or a fraction, n factorial is not defined. So what we can see here is n has to be a positive integer. It cannot be a negative integer. If it is a negative integer, then factorial notation is not defined. Also, factorial notation is not defined for fractions. So n has to be a positive integer. According to the above definition, 0 factorial makes no sense. However, we define 0 factorial as equal to 1. So the value of 0 factorial would be equal to 1. 1 factorial would be equal to 1, 2 factorial would be equal to 1 into 2 and that is equal to 2, 3 factorial would be 1 into 2 into 3 and that is equal to 6. So we can have different values for different factorials. Now n factorial could also be written as n into n minus 1 factorial. So we see that n factorial is what? N into n minus 1 into n minus 2 and so on up to 2 into 1. Now n minus 1 into n minus 2 and so on could also be written as n minus 1 factorial. So what we get? We get n factorial equal to n into n minus 1. or we can also write n minus 1 factorial equal to n factorial divided by n. Also, you got to remember that 2n factorial would be equal to 2 to the power of n into n factorial into 1 into 3 into 5 into 7 and so on up to 2n minus 1. 1, 3, 5, 7 are all odd numbers. So it is the continued product of all the odd numbers into n factorial into 2 to the power of n. So this is the value of 2n factorial. Let's take an example to understand the meaning of factorial. Find the value of 30 factorial divided by 28 factorial. The second part is 12 factorial minus 10 factorial divided by 9 factorial. And the third part is 1 by 5 factorial plus 1 by 4 factorial plus 1 by 3 factorial. So one by one, let's try to find out the values of these expressions. The first expression is 30 factorial divided by 28 factorial. Now, 30 factorial is 30 into 29 into 28 into 27 and so on up to 1. And 28 factorial remains as it is. Now this could be further written as 30 into 29 into this very expression is nothing but equal to 28 factorial. So this could be written as 30 into 29 into 28 factorial whole divided by 28 factorial. So we see that 28 factorial and 28 factorial gets cancelled, and what we get? We get the value of this expression as 30 into 29, and that is equal to 870. So 30 factorial divided by 28 factorial is nothing but equal to 870. Let's look at the second part, and that is 12 factorial minus 10 factorial divided by 9 factorial. Now this is nothing but equal to 12 into 11 into 10 factorial. We can write 12 factorial as 12 into 11 into 10 factorial, and this remains the same as 10 factorial divided by 9 factorial. Now if we take 10 factorial common in this factor, what we get? 10 factorial divided by 9 factorial into this is nothing. 12 into 11 is 132 minus 1. This further becomes 10 into 131. Here 10 factorial can be written as 10 into 9 factorial. 9 factorial gets cancelled from the numerator and the denominator, and what we get? 10 into 131, and that is equal to 1310. So the value of this expression is 1310. Let's look at the third part, and that is 1 by 5 factorial plus 1 by 4 factorial plus 1 by 3 factorial. Now this could be further written as 1 by 4 factorial plus 5 by 4 factorial into 5 plus 4 into 5 divided by 3 factorial into 4 into 5. What we have simply done is we have multiplied the numerator and denominator of this expression by 5, and similarly we have multiplied and divided this expression by 4 into 5. So what does this become? This is the same 1 by 5 factorial. This would become 5 by 5 factorial. 5 because 4 factorial into 5 is 5 factorial. And similarly, the denominator of this expression becomes 5 factorial, and the numerator is 20. So 20 by 5 factorial. When we add them, what we get? Equal to 26 by 5 factorial. Now 5 factorial is equal to 120. And 26 by 120 is nothing but equal to 13 by 60. So the value of this expression finally comes out to be 13 by 60. Now I really hope you have understood the meaning of factorial. Now we are going to look at the fundamental principle of counting. There are two fundamental principles of counting. The first is the multiplication rule, and the second is the addition rule. Now what are these multiplication and addition rules? Let's try to understand that. The first is the multiplication rule, and it says that if an operation can be performed in m different ways, following which a second operation can be performed in n different ways, then the two operations in succession can be performed in m into n different ways. So the multiplication principle says that if we have an operation and it can be performed in m different ways, and we have a second operation that can be performed in n different ways. Now if we perform both these operations in succession, then the number of ways in which both these operations can be performed in succession would be equal to m into n. Now this must not be clear to you right now. So let's try to understand this. Let us say that we have a city A and we have another city B. Now these are the different ways of going from city A to city B. So let us say that all these ways is equal to m. So there are m number of ways or m number of routes to go from A to B. A and B are the two different cities. Now let us say that we have another city C, and these are the ways or the routes through which we can go from city B to city C. And let us say that such number of routes is equal to n, or there are n number of ways to go from city B to city C. Now if I ask you, in how many ways can you go from A to C? Now you have to go from A to C. So that would be equal to m into n number of ways. So we see that there are m into n number of ways of going from A to C. So the multiplication principle is, if we have got m ways of doing the first thing and we have got n ways to do the second thing, so the total number of ways of doing both these things in succession would be equal to m into n, and that is the multiplication principle. Let's try to understand it through an example. How many numbers of 2 digits can be formed out of the digits 1, 2, 3, 4, no digit being repeated? So here in this case we have been given 4 digits 1, 2, 3, 4. We have to find out how many 2-digit numbers can be formed using these 4 digits, and the condition is none of the digit must be repeated. That is, we can have all these digits 1, 2, 3, 4 only once in the 2-digit number. So again, let's try to understand this. These are the 3 columns. This represents the first digit, this represents the second digit, and this represents the possible numbers. Now if I take the first digit as equal to 1, now there are 3 possibilities of having a second digit if we have 1 as a first digit. These are, the second digit could be 2, the second digit could be 3, or the second digit could be 4. So possible numbers would be 12, 13 and 14. Now all these are 2-digit numbers and in which none of the digit is repeated, and also they are from the digits 1, 2, 3, 4. Now it was a case when we took first digit as 1. Now let us assume that the first digit is 2. Now again there are 3 possibilities of filling the second digit. 1, 3 and 4 could be filled in the second digit, and again we have got 3 numbers which begin with 2 and end with either 1, 3 or 4, and they are 21, 23 and 24. Again let's take a case where the first digit is 3. Now again we have got 3 possible options of filling the second digit, and they are 1, 2 and 4. So the possible numbers when 3 is the first digit would be 31, 32 and 34. And finally we can have the first digit as 4. Again we'll have 3 options, 1, 2 and 3 as the second digit. So the possible numbers in this case would be 41, 42 and 43. Now how many total such numbers do we get? These are equal to 12. 3 plus 3 plus 3 plus 3, and that is equal to 12. Now we can also solve it in this way. The first digit of a 2-digit number can be filled with any of the 4 numbers 1, 2, 3, 4. So the first digit can be filled in 4 ways, and the second digit now can be filled in only 3 ways because one of the digit has been used for the first digit. So we are left with 3 digits, and any one number could be filled in the second place. So the second place could be filled in 3 ways. So total number of ways would be 4 into 3, and so what we get? Total such numbers would be equal to 4 into 3. The first digit could be filled in 4 ways and the second digit can be filled in 3 ways. So 4 into 3 would be equal to 12, and so the possible such numbers are 12. So in all there are 12 such possible numbers. So just using the concept of multiplication we have solved this problem.